Welcome to the Deep Dive. Look, we all know there's just so much information out there today, especially in areas like tech, right? It feels almost impossible sometimes to keep up, let alone feel genuinely well-informed.
It really does. And that's kind of where we want to step in. Think of us as your personal trainers, but for complex subjects.
Exactly. So today we're diving deep into software architecture. We've got these excerpts from a pretty dense book on it, and our mission really is to be that trainer for you.
Yeah, we'll break down the big ideas page by page almost. We'll pull out the crucial concepts, give you practical examples, maybe some analogies to make it stick. The goal is you get the essence without reading the whole thing cover to cover.
Okay, so what's the plan? First, we'll pin down what a software architect actually does. And trust me, it's way more than just slinging code.
Oh, definitely.
Then we'll look at how their skills are sort of structured using this capability model the book talks about.
Yeah.
We'll get into the soft skills, those, innate talents they
Oh,
need.
the human element.
And then the environment their software lives in, which sounds fascinatingly complex, almost quantum, apparently.
All right.
And finally, how you might actually plan a career or prep for an interview in this space. Sound good?
Sounds like a solid plan. Let's jump in.
Okay, so first thing, software architect. When you hear that, what usually pops into mind, I bet for many, is someone, deep in the code, maybe designing databases.
That's the common picture, yeah. But the book immediately paints a much, much broader canvas.
How so?
Well, it describes the architect as multifaceted. Get this. A de facto institutional agent of cultural transformation, an astute strategist, a gifted leader, instrumental solution provider, integrator par excellence.
Wow, okay. That's quite a list.
And it goes on. Domain-driven, socially driven, career-driven, and importantly, someone who trusts their innate talents.
That's a lot of hats for one person. So to make that a bit more concrete, maybe an analogy, the book mentions thinking like a city planner.
Exactly. It's a great one. You're not just designing one house or, coding one feature. You're planning the whole digital city. The roads, the power grid, the water supply, the zoning, even how the digital community interacts.
So you're shaping how people fundamentally interact with technology within that organization.
Precisely. It's about influencing culture, promoting the organization's policies, embedding best practices, setting standards. Ultimately, you're a driver of significant business and technological change. It's a very strategic role.
Okay, so if they do all that, how does a company even figure out what skills they need or how to assess someone? It sounds incredibly broad.
Yeah, it is broad. And that's where this software architect capability model comes in. It provides some much needed structure.
Right. How does that work?
The book puts it pretty simply. A software architect does what a specific organization needs, nothing more. This model helps companies hire better, match skills to projects effectively, and keep their knowledge base strong. For you listening, it's like a blueprint to understand the core functions.
A blueprint. Okay. Like building a house, you need a plan before you start hammering.
Exactly that. You wouldn't just start nailing boards together randomly. The book lays out a 5-step process for creating this capability model.
All right, let's walk through it. Step 1.
Step 1, provide requirements and specifications. This is ground zero. Every single architecture solution starts here. It's driven by what the business actually needs and the tech requirements to solve a specific problem.
So understanding the problem first.
Absolutely. The book calls this the problem domain, what the business is facing, and then the solution domain, that's IT's plan, how technology will address those needs. An architect needs to live in both.
Makes sense. So once you know the what and why, what's step 2?
Step 2 is identify software architecture practices. Based on those requirements, you figure out the specific occupations or work areas needed. So for that retirement planning app example in the book, you'd need application architecture and probably data architecture.
Okay, so going back to the house analogy, this is like knowing you need a residential architect, not a bridge designer.
Perfect analogy. And maybe you realize you also need a landscape architect for the garden. That's another practice.
Got it. And then within those practices, you get more specific.
That's step 3, establish software architecture disciplines. These are the specific knowledge areas or specialties within each practice. For application architecture, you might need disciplines like application modeling, application integration, or technical facilitation.
And for data architecture?
Maybe things like data aggregation or data management. For our house, the residential architect needs expertise in structural design, plumbing, electrical work, maybe interior design, too. Those are the disciplines.
Okay, practices, then disciplines.
Yeah.
What's step 4?
Step 4, add software architecture deliverables. Now we're talking tangible outputs. These are the actual work products that come out of those disciplines.
Like blueprints.
Exactly. For application modeling, the deliverable could be conceptual, logical, and physical architecture models, the actual diagrams. For application integration, maybe message flow diagrams or network maps. For data management, perhaps a data security model. These are the things you can point to.
Right, the concrete results of the work. And the final step.
Step 5. Quantify skill competencies. This is about measuring how good an architect is at producing those deliverables, usually on like a 0 to 100 scale. The book calls it a skill competency pattern.
So assessing their actual proficiency.
Yep. It helps individuals see where they need to grow and helps organizations check if a candidate really has the skills they claim. Like, how good is your house architect at structural engineering? 70%, 100%.
Okay, so pulling that all together, this capability model gives a really structured way to define, build, and even measure what a software architect does, tying it all back to what the organization actually needs delivered. It's practical.
Very practical. It demystifies a complex role.
All right, we've got the foundation with the capability model. Now let's zoom out a bit. You mentioned architects wear different hats, and importantly, they have to work together. This isn't a solo gig, is it?
Oh, absolutely not. The book really stresses this. It splits architects into two main groups, leading software architects and domain software architects.
Leading versus domain, okay.
And it makes a really crucial point. Leading software architects are incapable of providing solutions for the ever-expanding business and technological requirements on their own. They need the specialists, the domain folks.
Right, the scope is just too vast otherwise. So let's talk about those leading architects first. Who are they?
Well, top of the pyramid, you often have the enterprise architect. Think of them as the city planner or maybe the mayor of the digital city.
Okay, big picture view.
Totally. They provide those holistic solutions, making sure IT aligns with the overall business strategy, pushing for standardization, reuse across the entire organization. They're looking way down the road.
And translating that grand vision into something more concrete.
That's usually the solution architects. They're like the master builder or the architect designing a specific large building within the city. They bridge the gap between the big enterprise vision and specific technical solutions for major projects or initiatives. They create the detailed blueprints for those.
Got it. And then closer to the actual construction.
You've got the application architect, more like a specialized contractor, maybe the head carpenter on a building project. They focus on a single application or service, breaking it down, guiding the development teams on the details of that specific piece of software.
Okay, enterprise solution application, that's the leading hierarchy. Now, who are these domain architects, the specialists they rely on?
Right. These folks bring deep expertise. For instance, the data architect. Their world is data governance, management, security, integration. Super critical for handling sensitive info, making sure data flows correctly, all that stuff.
And given everything's moving to the cloud.
You absolutely need a cloud architect. They handle migrating and managing systems in cloud environments. Think AWS, Azure, Google Cloud. They figure out the strategy for moving and running things there efficiently and securely.
Security itself needs a specialist, I assume.
Definitely. The security architect, their job is protecting everything from cyber threats, designing defenses against hacking, preventing data breaches, ensuring compliance. Hugely important.
And one more, you mentioned links back strongly to the business side.
Yeah, the business architect. They're crucial for interpreting what the business actually needs, checking if proposed tech investments make sense financially, and making sure solutions align with the big picture enterprise roadmap. They ask, will this actually meet a market need and make money?
What really strikes me here is the emphasis on collaboration. You painted a picture of a team sport.
It has to be. The book gives examples like an application architect needing to work closely with a data architect because, well, their app handles data, right? But the app architect might not know the deep intricacies of data modeling.
Or security needing to be baked in from the start.
Exactly. A solution architect proposing a new system must partner with the security architect to ensure it meets all the security policies before they even start building. No single person can know everything required for these complex systems. Teamwork is just non-negotiable.
So the real power isn't in one genius architect, but in how these different specialists collaborate and orchestrate their skills. That's the key takeaway.
You got it.
Okay, so we know the technical skills, the collaboration, but what about the person behind the title? The book talks about innate talents. What makes an architect truly effective beyond the technical stuff.
Yeah, this is a fascinating part. The good news, according to the book, is that these aren't necessarily fixed traits. Things like adaptability, enthusiasm, curiosity, creativity, self-discipline, they can all be developed and enhanced.
That's encouraging. What are the key ones the book highlights?
It focuses on four. First is the power of creativity. This isn't just about art. It's about instigating change, dreaming up new software design approaches, diversifying investments to lower risk, and combining different ideas in novel ways.
Like a chef experimenting with unexpected ingredients.
Exactly. Finding that surprising combination that works beautifully.
And related to that is imagination.
Yep, the potency of imagination. Imagination fuels creativity. It lets architects visualize and conceptualize innovative software implementations before they exist. It's about mental modeling, experimentation, taking calculated risks on new ideas, being able to almost see it working in your head.
Then there's one called Software Design Aesthetic. That sounds interesting. Artistry and code.
Kind of. It's a sensitivity to colors, shapes, structures, and space, and how those visual and structural elements impact the user experience. It's balancing the pure technical stuff with making the software intuitive, appealing, even pleasant to use.
Like a well-designed building isn't just functional, it feels good to be in.
Precisely. Form and function.
And the last one
Yeah.
seems fundamental.
Curiosity attributes. This is that inquisitive appetite for learning, for finding out about unfamiliar things. It drives exploration, diagnosis, asking why constantly. It pushes architects to discover new ideas and better solutions, like a detective always looking for more clues.
These talents really seem tied into career development, don't they? The book then brings up self-assessment.
Absolutely. It calls self-assessment a self-discovery process. It helps you understand your own strengths and weaknesses in key areas like your social intelligence for collaboration, your grasp of software architecture practice itself, your leadership potential, your strategy skills.
And knowing yourself helps you find the right path.
Exactly. This self-awareness helps you figure out what kind of architect you want to be or what roles fit you best. Are you driven more by the social aspects, pure technology, leading teams, or high-level strategy? It helps you tailor your career.
So being a great architect isn't just about coding chops. It's about cultivating these innate talents. Creativity, imagination, that eye for design, and relentless curiosity in understanding yourself well enough to leverage them.
That's the essence of it. Continuous development on all fronts.
All right, let's shift gears. Where does all this software, designed with such care, actually live? It's not just files sitting passively on a server, is it?
No, not at all, according to this book. It introduces the idea of a software architecture environment. Think of it as the entire production ecosystem where all the applications and systems are deployed, run, and managed.
Like the digital city we talked about earlier.
Exactly. The environment is the city itself, the land, the roads, the utilities, the climate, and crucially, how all the different software buildings interact. The goal is to design this environment for balance, for stability, for business continuity.
And within this city, there are different kinds of structures.
Yeah, the book talks about micro-level structures, the basic building blocks, things like atomic solids, which are like those fine-grained, specialized microservices, small, focused, maybe unbreakable in a sense.
Okay, small and focused.
Then you have things like monolithic solids, which are more like those older, big, tightly coupled systems where everything is interconnected, sometimes in messy ways. And then there's the macro level, which is described as the 3D fabric, holding everything together, managing the relationships between all these pieces across the whole environment.
Now here's where my mind got a bit blown. The book calls this environment an uncontrolled quantum landscape
Yeah.
with unpredictable behavior. What on earth does that mean for software?
Yeah, it's a pretty wild concept. It basically means that even with the best design, the actual behavior of software in a live dynamic production environment can be somewhat erratic and hard to predict perfectly.
Why is that?
Well, think about it. You've got constant changes, new code deployments happening all the time, technology upgrades, maybe shifts in business strategy that weren't planned for initially. All these things influence how the software behaves.
Okay, so it's constantly in flux.
Right. And the book introduces this really provocative idea of an intelligent topological space. It suggests we can almost think of software products as like artificially intelligent decision makers. They learn behaviors, they form relationships with other software, almost like a social network, but without humans directly involved in those interactions.
Whoa. So architects are managing invisible forces between these intelligent software agents.
In a way, yes. The book actually talks about specific forces. There are gravitational forces where maybe a central important system naturally attracts lots of users or other systems, like a popular downtown building. Its gravity grows as it's used more.
Okay, like network effects.
Kind of. Then you have competing forces, where different software pieces might literally fight for limited computing resources, CPU, memory, network bandwidth, just to survive and perform.
Survival of the fittest software.
A bit like that. Ideally, you cultivate harmonizing forces, where different software products work together smoothly, synergistically, promoting stability.
But there are bad forces, too.
Oh yeah. Disharmonizing forces, these cause chaos. Things like extreme isolation, where a system can't communicate, or radical software distribution, making things too complex, or excessive federation, or just plain old too much redundancy, causing conflicts.
This sounds incredibly dynamic and challenging to manage. How do architects actually bring some order to this quantum landscape?
It's not about perfect control, because that's impossible. It's about continuous management through iterative design activities. Basically, constantly tweaking and adjusting within a software construction lifecycle.
And they have specific tools or techniques for this tweaking.
Yes, the book describes design tools that metaphorically modify the dimensions of the software structures within this environment.
Dimensions,
Yeah.
like length, width, height.
Exactly like that, but applied to software constructs. They can thicken and contract, adjusting the width by adding or removing features or functionality. Think of that as the x-coordinate. They can lengthen and shorten, modifying the length, often through scaling, adding more instances of a service to handle load, or reducing them. That's like the y-coordinate.
Scaling up or down.
Right. And they can layer and delayer, adding or removing hierarchical structures or tiers, like separating database access into its own layer. That's the z-coordinate, adding depth or simplifying.
So it's like architects are constantly sculpting this living digital environment, adjusting its shape and structure in 3 dimensions to keep it balanced and functional.
That's a great way to put it. It's ongoing urban planning for a constantly evolving digital city, managing these complex, sometimes unpredictable forces through careful, continuous design adjustments.
Fascinating stuff. It really expands the definition of architecture.
It really does.
Okay, so after exploring what architects do, the skills they need, the environments they work in, the big question for many listeners might be, how do I actually get one of these jobs?
Right, the practical career stuff. The book is clear. Preparing for an architect interview isn't just tactics. It's a strategic endeavor. It's about playing the long game, avoiding being underemployed relative to your skills, and always, always developing.
So, strategy, not just quick prep. Let's break down some practical advice for, the aspiring architect listening. First step seems to be really dissecting that job description.
Absolutely crucial. Don't just glance at it. You need to properly analyze the summary. Why are they actually hiring for this role now? Understand the responsibilities. What will you really be doing day to day? And scrutinize the skills. What specific expertise are they looking for?
The book suggests organizing this.
Yeah, it even shows making a findings table. You'd note down the architect type, enterprise-solution.domain. The business reason for the role, the expected deliverables, the specific expertise needed. It helps you map yourself against the role systematically.
And understanding your own expertise is key too, right? The vertical versus horizontal thing.
Yes, understand knowledge scope. Know whether you have vertical knowledge, deep, narrow expertise in one area, like performance testing, or horizontal knowledge, broader skills across multiple areas, like an enterprise architect needs. You have to tailor your resume and how you talk about your skills to match what the job demands, depth or breadth.
Okay, tailoring is key. And researching the company, that's standard advice, but what's specific for architects?
For an architect, the research needs to be deeper. Research the company thoroughly. You need their business view. What's their mission, their strategy, their business model? Even do a quick SWOT analysis, strengths, weaknesses, opportunities, threats.
Beyond just the business side.
Critically, yes, you need to figure out their environment technology stack. What systems, platforms, databases, cloud services do they actually use? Dig into news articles, company reports, maybe even LinkedIn profiles, people there. The book suggests libraries, trade shows, anywhere you can get intel.
Okay, deep research done. You get the interview. How do you talk the talk?
You literally need to adopt the lingo. The book says it flat out. Talk about software architecture principles like separation of concerns to achieve loosely coupled designs. Mention best practices, maybe a buy versus build analysis you've done, referencing standards like TOGAF or relevant ISO standards, the established frameworks.
And policies.
And policies, yeah.
Hmm.
Like understanding accountability for software in production, using this language shows you belong in the conversation.
Makes sense.
Hmm.
What about the actual questions? What should people prepare for?
The book groups them into categories. Expect behavioral questions, how you handle teamwork, communication, leadership, like how do you get stakeholders to buy into your vision? Classic stuff.
Standard behavioral. Got it.
Then skill assessment questions about your direct experience, your training, maybe times you failed and what you learned. And definitely architecture attributes questions. These are about the non-functional requirements, scalability, reliability, security, availability, elasticity. You need to be able to discuss those intelligently.
What else?
Software architecture lifecycle. Questions about the whole process, from planning to maintenance. Business concepts. Questions showing you get how business needs drive design. Like, how does the company's business model affect your software design choices?
That connection back to business seems vital. The book also mentioned user stories as a good tool.
Yes, a great technique. Explaining a complex technical solution using a simple user story makes it instantly relatable. Frame it like, as a customer, I want to be able to reset my password easily so I can access my account if I forget it. It grounds the tech in user value.
Smart. And understanding patterns and styles.
Absolutely essential. Be ready for questions on patterns and styles. Know the difference between high-level architecture styles, layered microservices, SOA, mid-level architecture patterns like specific ways to implement microservices or a master data hub pattern, and low-level design patterns like API gateway, circuit breaker. Know the hierarchy.
And finally, problem-solving questions.
When you get a problem-solving scenario, the key is start with the business problem first. Don't jump straight to tech. Analyze the root cause, maybe mention needing evidence, then propose your strategic tech solutions. Show that methodical, business-first architectural thinking.
Okay, so the big takeaway for interviews is be strategic, do your homework deeply, speak the language, and always connect technology back to solving business problems.
That's the winning approach.
Well, we aim to be your personal trainer for this deep dive into software architecture, and hopefully that's given you a real shortcut to understanding this complex field.
Yeah, we've covered a lot of ground, what an architect is, how their skills are structured, the different roles, those crucial inner talents, the dynamic environments they manage.
And even how to approach landing a job in the field. You should now have pretty solid grasp of the core concepts.
It really is a fascinating world, that constant interplay between careful structure and dynamic change, between the science of engineering and the art of design. Architects are truly building the invisible foundations of our digital world.
So, as you think about everything we've discussed, here's a final thought to ponder. In this constantly evolving digital city, what part will you choose to build? How could your unique mix of skills, your curiosity, shape the architectures of the future?
Keep diving deep with us. Keep learning, keep building. Thanks for listening.